Hello students, welcome back. This is the internal forces. We are now trying to draw the twisting moment diagram for certain problems. Earlier I have explained the shear force and the bending moment, and then axial force bending moment diagrams, and then axial force diagrams. Now it is a turn for the twisting moment diagrams, and I have taken the example from Crandall, Dell, and Lardner's book. So straightway passing through the axial force diagram problems and then opening the twisting moment diagram. Yes, so this is the twisting moment diagrams. So there are discs. Please ignore the discs. Our main concern is the shaft, which is a circular one A, B, C, D. So the torques or the moments, twisting moments, are applied around the x-axis, which is the axis shown here, with the moments TA, TB, TC, and TD with the magnitudes shown on the right side and the direction shown onto the diagram. Now you need to draw the twisting moment diagrams for the shaft. So AB, BC, CD, these three shafts. So how to draw it? Again, the same approach. First, we'll solve the equilibrium problem. We'll draw the free body, and then from there, we'll take a section at a distance x1 and then find out that what is the equilibrating moment which should be applied. Once again, please notice and please uh, just refer back to the diagram we have started with in the very beginning of the basic concepts of the internal forces, that when we are on the positive face, there is a circular cross-sectional face here from which the x-axis emerges, and there you will find the consistent notation for a positive moment is actually this way. So this mx1 moment, I am assuming that it is in equilibrium with the this part of the shaft. So there is a Ta moment acting. So Ta plus mx1 is equal to 0. So I will get an mx1 minus Ta. So I was wrong. The Tx, it should be in opposite direction. But anyway, I'm not going to revise immediately. Rather, I can take a section at a distance x2 and then do the same exercise again mx2. I find mx2 is minus 20. So again, I was wrong that mx2 is in other direction. Similarly, if I am just going in this way and find out that what is the mx3 at a location here, and then draw finally the twisting moment diagram, it can show that you can now refer back that what does this diagram means and what this negative and positive means, and then refer back to the first diagram you have drawn for the slender members to define your positive sense for the positive faces of the slender member cross sections, and you will find that it should be consistent, and it is this diagram how it is drawn. Now the next is the bell crank mechanism, where there are two forces acting and you are asked to draw the twisting moment diagram for the shaft A, B, C, D. Please mind that the bell crank is a mechanism which I don't need immediately. I will immediately replace the bell crank mechanism with an equivalent force into the same direction and a moment. So P2 is 10, and since this system is in equilibrium and the supports are need to release the moment about x-axis, then this is the bearing support, so they cannot withhold the moment, so they have to release the moment here. So the only way the system can be in equilibrium if the total moment p2 into 1.5 distance is p1 into 1.5 distance. Since the distances of the bell crank mechanism is same, p2 is equal to p1 is equal to 10 kilonewton. So if this is so, then this is the free body diagram of the entire structure. And I have not attempted to solve it because all the other forces are irrelevant right now for me, excepting the twisting moment. So again, for the twisting moment diagram, I take a section at a distance x and then try to find out that what are the actually at a distance x I consider a section and what are the moments and forces. I have drawn the bending moment and shear forces as well, but I am not attempting to solve them. Rather, my full attention is to the moment 15 kilonewton here, and I can see that the mx is actually coming to be negative, and I have an other direction. So it is 15 kilonewton is a negative this thing. So now, if it is negative, so I have drawn it this. So you can now infer from that that this part is only twisted. Since there is a release at both the sides with the bearing, they are not twisted. They will remain straight. And the diagram shows that. So P1 is equal to P2 and also the twisting moment where it is released. and the mid portion only is subjected to twisting moment. In fact, the problem is very, very complicated and complete 3D vector treatment with the shear forces and bending moment as well. With there is no axial forces along x direction, but the shear forces are very much there. Bending moment in two different planes are there, and the resultants will be in arbitrary direction. All these things are to be explored from the reference if the student is interested. Right now, that's the end of the lecture because we have completed a few examples and given you the guide way for drawing the twisting moment diagram for structures. Thank you very much.